Today what we want to work on, I want to work on some of the little fine points of making the nacelles, and let me just start with what we're going to do with a little storyboard so it'll make sense, because it may not make sense as I'm actually making the parts. We have to take into account, and this is exaggerated, that the A26 has a dihedral angle, and that wherever we place the nacelles, what we want to have, hopefully, is that the two engines are parallel, looking from the front. Now, unlike the B25, where they cant out at 5 degrees, and that was kind of a trim problem I didn't want to deal with on the A26. So what we want to do, number one, is get the two engines in this dimension that they're both straight up and down. So this is the first part of what we're going to try to do, is I'm going to try to make a bar. Once I make these parts, I have a piece of channel aluminum. I'm going to try to make a bar so that the two crutches can sit on the bar, bolted right through. And what I can do is take this whole piece and hold it up, and this will ensure that the two crutches are in this dimension. Now also I have to take into account that because I've made these, let's call them crutch sides, what's going to happen is when we go to align it, the inside one is going to need a kerf taken off. The outside one might need a part added. I don't know until we start getting the alignment. We also want to make sure that datum line, remember on the last video I did a lot of alignment work because we were working with another friend that's doing a Spitfire, and trying to get the center line of the wing and the datum line so that from the side view, of course, this is not going to look like this. Our crutch is going to look something like this when we're done, but we're going to make sure this datum line and this center line are in good alignment. And we have a couple of ways Les has envisioned doing this, a couple of ways I've envisioned doing it. But basically we want to get the motor thrust lines, wing center line, and this crutch. The way I'm going to get the motor center line is by laying a strip, hopefully. We don't know, Les brought some spruce. But getting these alignments on a twin engine plane, a multi-engine plane, this is a lot more than a single engine plane. But we really are going to spend the time. We're going to make this bar jig. We're going to take and make a cradle out of the foam cradles to hold the wing in perfect alignment while we're lining everything up. Again, this was very complex, and this is one of the challenging parts of making any twin engine plane. All these alignments, if they're not right, this plane is not going to have that nice flat corner that we're hoping it will. So the first part of this whole operation is going to be to get the mounts onto the sides so that this bottom line is going to be our datum line. Our datum line for this alignment project, and then we're going to be able to measure the center line of the wing to the datum line. That's going to be our critical area. But in this case, since the wing is going to be upside down and on a glass table, what we'll be able to do, and we know the table is flat, is we can get the wing level to the table, and that's relatively easy to do. You can shim it with IBM card sheets of paper, get it accurate. And then our datum line for these motor installation, if you can envision how that's going to work, I haven't thought of a better way of doing this. Les and I have gone back and forth 1,000 times on how we want to do this, but I think this is going to be a time-consuming way, but in the end, this is going to be something that's going to work perfectly. The other thing is I'll make this, I'll call it a alignment jig. I'll be able to use that when we do Mike Costello's twin also, and that'll ensure that his two nacelles are aligned and that any variance in them we can take care of. Now as we look at the nacelle drawing, and of course our doublers are laminated with 64th ply on both sides. These are ultimately going to go in position, but we need to establish a datum line. And the datum line is what's going to be important here. And then we need to establish where our mount is going to go. Yeah, the way we plotted this, because again, remember the bottom of this is the datum line. Normally it would be the top, but everything about this plane is different. Using that hole there, and using this as my alignment, I scribed the line that'll be the top, the hard point of the motor mount crutch. And now I can replicate this on all the other three pieces. So I know I have my datum line and the top alignment as a straight line. Now the key issue is here that these are exactly the same. So just as a double check, I can lay them on a flat table. Make sure all my center lines, in fact front to back, should be exactly the same since we're working off a flat. Now what I did just as a little insurance policy, I put the line on both sides of all the doublers. Double checked it, and by the way, this was a real nice thing, having the drawing pens worked really well. We've put this on the video before. These are really nice. I think Elliot was the one or Les, I'm not sure who gets the invention award for that. Now the next thing is we need to figure out, and what we'll do is we'll do this with CA and we'll tack it first. We need to get exactly the alignment we want, front to back, top to bottom, and I have to go back to the plans for that. See that to get the proper alignment, this crutch goes right almost to the front of the wing, but just leaving maybe a hair in there. It's going to leave us some room to, if we have to sand that out just a little bit. So what I want to do is, before I make a permanent glue seam, I want to just tack this together, 1 or 2 drops of CA, and then I can check all my dimensions. Now from this point on, we know that that's just tacked in with just a few drops. And take another side. See, what I'm trying to do is establish that these 2 datum lines are exact, and that when I tack the crutch together, they're exact. And before I make a permanent glue seam there, well, I don't want to have that I have to go back and do it over again. What's all the glue I want holding that for right now? Well, it's tacked, of course. This looks reasonable, but if it wasn't, right now before we glue it, this would be the time to set it straight. Now we have both pieces flat, and our mounts, just like the drawing, our mounts are now relative to this datum line, and our 2 datum lines are parallel. Now we can permanently glue that. Okay, now anytime I get the glue seam in there on end grain, let some soak in there. Now each time I put another permanent glue seam on there, I'll go get my triangle and check that I'm not building in some kind of crazy alignment. Because at this point in time, it's still a very delicate piece of structure. Now, what's nice about doing this type of mount you can actually get glue right inside. Now what I do is let it roll in all dimensions. And then just make sure there's not, yeah, one drop came out, okay. Oh, if anything better, they're fuel proof than just plain old thin CA. Let it sit on there, let it soak in, especially here you have some end grain, wipe it out. The days when people used to put gallons of epoxy in there, hoping that was going to fuel proof it. I remember fixing, I think it was Waldo Carville's plane. I'm not sure, no, it was Mike Cooper's plane. And he had, I'll bet you, he had used, just 4 or 5 tubes of epoxy, just painted it all in to fuel proof it and served no purpose other than to make it heavy. Now the thing to check here, this is, we know we have 5-ounce tanks in the B25. We know we didn't need them that big. We want to make sure we can also put a little bit of that so we'll get a clean shut off. That's the other part of this. Now, we're assuming we're going to need 4.5-ounce tanks, but I'm going to try to make this go as far back as it goes until it hits the wing, which is going to give us probably 5 ounces. Maybe we'll be able to. Maybe we will be able to put 5-ounce tanks in here. You never have tanks that are too big. You can always put less fuel in. And in the case of the B25, I was taking fuel out as a way of balancing it out. Okay, so we know we have a nice straight, relatively straight datum line. That's the thing I'm constantly working on here. And before I make the second one, I want to true this up over on the sanding bar, and I'll have one of these done. Again, every step of the way, checking that I'm not building a pretzel and it's crooked and it's twisted. Use that 90-degree triangle. Anytime you're in doubt, just check it. Now this is where we get that final. Just make sure they're both parallel, both in good alignment. Remember that bottom edge is our datum line. I checked everything. I am really happy with the way that worked out. Now, the only thing left is, and through the magic of video we can do it off camera, is just turn these other parts into another crutch, basically replicate everything, and then I can go and rate them and see to put the lighter one on the inside. Yeah, they'll probably be very close. Even the crutches were only a gram or two different. Boy, don't you wish in real life you could just make things just appear like this, make one, and the second one would just come out like an ice cream cone? Well, the second one always goes a little bit faster, but I made sure all the joints had good integrity, and this really was a surprisingly good alignment. I was really impressed with how nicely that lined up. Now the next thing we're going to have to do, and I have to go get the material, I got to get that piece of channel iron. It's actually channel aluminum. Clean it up because it's 1,000 years old. And get it drilled and tapped so that we can use it as an alignment bar. So you can see how this is aluminum. I don't know how, I have to go measure how much I need to cut. But we just happen to have this in inventory. That's the reason I'm using it. So the first step we need to do is figure out exactly how long this bar has to be to get both of these aligned. And I'll make it about a quarter of an inch or a half inch bigger than it has to be, just so we have some room out on the edge. So I'll measure this out carefully, center to center. I actually could do it off Dave's plans, but since we have the model, may as well use the model. And then I need to take all the paint and grease and everything that's off of that piece of aluminum. Now, if you didn't have a piece of that L-angle aluminum, and you were doing a twin, you obviously, one of the choices you'd have, you could borrow mine, because once I finish machining or making this part, we'll have it for everybody, and we'll just keep it in inventory. Now we know it's 9.5 inches between the nacelle centers, so what we really have to find, and one end of this is already cut, is going to be a 19-inch piece of this material. And that's going to be the center, so we want to leave an inch more, about a 21 I guess would be safe to make it. 21. I want to leave a little extra material. And because I'm going to have to peel off all this paint and everything, and hacksaw this, I guess the only way I can do this is look at this silly thing. Get a hacksaw on this, get all the burrs off it. I found, and this blade you can see has been used. The problem is here we don't have a lot of pre-tools, but we have a lot of tools that should be well worn. If we had a brand new blade, this would be a good time to put it in. Nice to have power tools. Yes! The idea is any really sharp edge this. And this edge here, this is like a giant razor blade. One of the things we have here, this, I don't know what this is, paint or something. Not really. Maybe that one. One of the other choices I have is to just get a propane torch and burn that off. Looks like this is some kind of plastic or something, and it's not even paint. And I decided against trying to torch it off. The real reason was I hit this with the torch and I had a terrible smell, so it's some kind of plastic coating. I guess it isn't real important that we get it off, other than I'd like this tool to be a permanent part of the shop. And I don't want to I'm trying to keep the smell down. I don't want to be torching this off. We want this to be a relatively nice piece of equipment when we're done. Or something we can loan out. I have a sneaking suspicion that this is not the last twin I'm ever going to build. And after seeing this, I got this, by the way, I mentioned this on the last video. I got this video from Warren, finally, of the 2002 Reno Air Races, and there's a tiger cat going around the pylons. Now, I've already made a tiger cat, a profile one, years ago. In fact, I gave it to Augie Buffalano to fly in sports scale. That was a lot of years ago, but in the meantime, I'm still a tiger cat lover, believe me. And that would make a very unique stunt ship. Anyway, we're just going to have to chip away at this, it looks like. Or else in the worst of all worlds, I can just take it outside and torch it, I guess. But it's really cold out there. I don't want to go outside. I'm going to stay inside. That's what I love about building, staying inside. Next step on this. What a pain that was. Get the grit and the glue and everything that was off there before. Clean it up. Since we're trying to make what we hope is going to be a permanent tool, any kind of wet and dry paper will just get this cleaned up. And then the last thing we can do is polish it with SOS. And that should give us a nice permanent tool. And because of the shape of the angle, it should be able to stay relatively straight, and should stay perfectly straight, in fact. What do you want? Hey! Who are you talking to, Chicky? I'm the only one here. Who are you talking to? Anyway, a lot of times you resist the idea of spending a couple hours making a tool like this, and you think, oh, dude, I only want to use it once or twice. Let's just slap it together. Well, I think it's, in my case, I'd just rather spend the time. I know Les is big on making tools too, and in our case, because Mike is making exactly the same plane, I'm really making, I'm doing this for him. He's getting a free ride here, one way or another. And usually, I always keep some SOS here. This will leave a nice finish on it. And then we're ready to lay out where the motor mount pads are going to go. Drill them up. And hopefully real soon we'll have a nice, the basis of our new tool. And that should maintain good alignment. Quiet, Chicky. I did put some tape on there just so I can get my center lines on. Now this is going to be the center line, and this has to line up with the center of the wing. We're going to make some kind of way of lining this up. Now also what's going to happen out here, this is going to be the center of each nacelle, and we're going to make a pattern to transpose the bolt pattern out here. Start by truing up a piece of 60-foot plywood, just double check that we have a 90-degree edge. We could use a little piece of aluminum or steel, anything, it really wouldn't matter. What we need is a little template so we can transpose those motor mount holes out onto our beam. And to make this pattern, it's relatively straightforward. I want to take this dimension, since we know we're working with all 90 degrees, hopefully. We know that's going to be the spacing in that dimension. As long as you're working with all 90s, this should work out relatively well. Now we know that's the dimension, and we also need to pick up this dimension, and it's not ultra critical. Again, we do have a couple of thousandths of play in the bolts, and we need a little bit of play so we can line these up in the ultimate test of things. This should get us close enough for now. We luckily enough have hit it fairly well. Now we need this is going to be our template. Next thing we have to do is figure out a center line on this. We need to get a center line. Exactly a center line on there. The rest of this we can trim off later, but now we have an accurate layout. We can lay this up on our mount and spot the holes. What this does, this allows me to get an accurate spot, hopefully. I think I moved it over a few thousandths. What I'll do the first thing is drill pilot holes. Make sure I'm accurate. This is my center line now for the center of the ring. Once this lines up with the center of the ring, each nacelle center line is 9.5 inches off center. Final tool, it'll be a little helpful to Mike when he, I guess, puts the bolt holes in the crutches and things like that. He'll have a nice little template to work off. Tip is to go through our special stainless 440 bolt selection here. We got only the short ones. Make sure I hate to cut up long ones. Look for some the right size, because what we want to do now is hook the crutch right in place. Let's see if we got any short ones here. And I cleaned this off. I put a little notch in there where that's the center line. Now the next thing would be to just run some bolts down in there and then see what kind of alignment we have on it. Now what we did, I laid this back on the table and made sure all my datum lines were parallel, which they in theory should be, but checking them on a flat glass table, these two lines and these two lines perfectly parallel. Now we're ready to jig up the wing, and that's going to require cleaning off the whole table and just rechecking that we haven't lost any of the alignment that we put in the table last time we did this. It's always good to check it before each time you, and in this case, do anything that requires some alignment. Make sure that table is flat and doesn't have a warp in it. If it does, just shim it up. Now what I did, just to stiffen this up a little bit, I got the epoxy drying. I had this piece of spare wood that we used to make dihedral brakes, and I epoxied it right in place. I got the tape holding it up, because what it does, it just makes a nice solid. What was happening before, this actually was springing just enough that it was annoying, and every time I'd go to make a test, I wanted to see that everything was in alignment at the same time. It was out by a little bit. So what I did, I trued it all up and filled that with epoxy, and now it's right on the money. Every one is right down there. The test, of course, is just to look down and see that everything is parallel here. Well, once that epoxy dries, then I can, just using my sanding pad, just kiss each edge, make sure I have two perfectly flat surfaces, and that'll be ready for the installation once we get the wing jigged up. That's the next step. As a final test here of how we can get this aligned, this is some real nice straight spruce. And what I want to do, I want to set this up in such a way so that when this is in the jig, this is going to measure the datum line out past the back of the wing. Otherwise we can only get a measurement up in the front. So what I'll ultimately do is just tack glue this in place so that I'll have two datum lines to work from. And I only really need one on each side, because what we're going to have to do is eventually take some of that material away inside. When this is going to sit in the V, a little bit of that is going to disappear. So little by little by little, I don't want to distort this datum line. This is the datum line that I need to make sure this is accurate. So I'll just tack these on, and once those two, that'll reference each one of the nacelles separately. Where are you going? Again, these little alignment bars that are going to work off the datum line. Of course, what we're counting on is that we're going to run them right into a flat table. I also checked that my spacing, I don't have these in crooked so far anyway. And this bar really did need the reinforcement. It's a lot easier to handle that way. So the next thing, and I'm not going to even try to do it today, it's just getting late today, I'm going to have to clear off my whole workbench here and get ready to lay out those cores and make some kind of a jig to lay this 70-inch wing on this flat table. And it's just too intense of a job to do right now. I don't like to start something like that at the end of the day. I like to have the whole day ahead of me while I'm doing that. Have a good cup of coffee tomorrow morning and we'll get back here and work on this. Not today. I wanted to dedicate the better part of a day and hopefully get these 2 nacelles installed today. Now, here's the point. If you're going to start this, the best thing in the world is make yourself a nice hot cup of coffee. In this case, I get up before the family. And I want to get this started. I want to get the table all squared away. I don't want to be doing this and in the middle of the day have 1,000 phone calls if possible. Now, because they're predicting more snow today, actually the next couple of days. This is our friend Butch, by the way. That's Butch. He hangs out at our feeder in the winter. Getting a nice early start like this is so important when you have a job like this. Coffee, get ready. I'm excited about this. The mistake is always get down to shop and it's the end of the day and you try to get something started and you don't finish it. I definitely want to get this started and I want to get it at least installed today if that's the only thing I do. I'll dedicate the better part of the day to doing this. As soon as I have breakfast, I am going to get down there. We're ready to start this alignment job. Alright, let's get this job started. First, let me do a little storyboard and show what is really going to be involved in this in a simplified version. Because you can use this information on virtually on any plane, virtually on any fit. This is a fit dissertation. Now, when I bought the original piece of rental property I own, and John DeTavio and I spent 1.5 years renovating it, one of the first things he taught me is what's called a sheetrock fit. Now, when you buy an old house, what happens is you think the rooms are square, but they're not. The rooms all turn out to be really parallelograms. In a lot of cases, what happens is you would even have something like this in a worse scenario. And what you want to do is fit a flat piece of sheetrock up into this area. So what you would try to do is take, let's say this is going to be just to make an example of, and here you have this flat piece of sheetrock you want to shove up into here. Well, you want to just get the first part that it hits on. It's called the hard points. Find the hard points, take a little material away. Move this further up. Now what happens is as you have this, you're constantly shaving away at the part that hits until these 2 sets of teeth kind of align. Now it's no different. In fact, it's very similar when you have a wing opening that may or may not be an exact within a pencil line of what you want. So when you go to put this into the fuselage, a lot of times there'll be a hard point and you need to shave this away because you'd like to get as big a footprint as possible. You'd like it not to just be hitting on 2 or 3 points and everything else in here is big gaps of air. You like nice tight fits. Now in the case of the A26, we want 2 of these to line up exactly the same. So we have the wing already jigged up on a table, and I know the wing is relative to the table because I have my indicator that John Pothier made for me, but you can make something very similar. And I know that the center line at the back of the wing, center line at the front of the wing, and I only really need to reference it right now. I need to reference it exactly in the center of the wing. I can't be bothered referencing it further out because I know the whole wing should be parallel. Now, once I have this, then I know as I go out onto the wing, the spot where the nacelles is going to be, I really don't have to reference it other than to make sure that if we look from the top view of the wing, I don't want to measure it this way because we have dihedral to account for. I have to be relatively straight. What that's going to give me is when I have the front and the back the same height off the table, then what I know for sure is when I set in these mounts and I have this bar, this spruce bar, I can measure from the bar down and the bar down, of course the table is bigger, and I can get that. I know that that's going to line up my motor mounts to the ring center line, and that's a critical thing. And is really, when you're doing a twin engine plane, this gets a little more complicated than you think it is in the very beginning. But doing this kind of a sheetrock fit, now we're going to be doing this, and I'm not going to let the camera run because this really does get time consuming. In fact, I get bored to death doing this. But I know I have to commit the better part of a day. I have to start laying the part on and finding the hard spots and shaving away until I get a really nice fit around where I want that to be. Then once I get that fit, I need to go put a tack on it and then reference and see if I have it in good alignment, and if I don't, of course, break the tack and do a final adjustment either with a little shim or with a little more shaving. But this, in the alignment of this aeroplane, today is going to be the day we make or break this aeroplane, because if these nacelles are not on straight, or if we don't get the wing into the fuselage relative to the stab and elevator straight, if we get one of these things out of misalignment, we're really not going to have a fun time at the flying field. If we spend this day diligently and take plenty of time getting it right, and in my case what I can do is when I'm all done, because I have the laser, I can check it with the laser. And the laser as much as, I think it's as accurate as you possibly could ever make it with the laser, but to rough get it in there, I have the, let me show the tool. And you can always improvise here. What this is this sits on a flat table, and then I set this for my height, front and back, and then I reference front, back, front, and just keep adjusting it until I have it exactly right. Now, in the past, you can even use a piece of balsa wood with an incline on it. You can use a triangle. A triangle, by the way, works fine. And once you find your center line, put a piece of tape on here and just put a little scratch. Doesn't matter. You don't need to have fancy exotic tools. What you need to have is the time and energy and commitment to get the alignment as accurate as you possibly can. Yeah, this looks real simple, but this really consumed a couple of hours. Because what I have is I cut out the part of the foam core where the nacelle would be. I had to jack up the front accurately, and this is really not ultra accurate because the wing is already in suspension. I just wanted to give it to some support. I sanded away the finish to find a center line right in the front. You can see we still can reference that. And then make sure I'm on the center line front and back. And also the center line here tells me where the edge of my nacelle should be. And I measured the two nacelles at 3 or 4 different points to make sure they're parallel this way, that they're not off on an angle. So once I have this dimension, let me move this back a little bit, and I can check this. The more angles, the more places you can check this. And then when I'm all done, the final test is the laser. Now, another way that I've seen, I put a towel on each end of the wing. Another way I've seen people do this that seems to work pretty well is they take the top of the core and then put weights on top of the core. Well, when you have a dihedral, this has an inch of dihedral, well, I'm afraid that's going to distort that somehow. So I'm trying to do it with soft towels. It spreads the weight out and takes into account the angle. That was my motive there. Now, in a dry fit, what I'm going to try to do, I made these pieces up yesterday. I mean, in a typical dry fit, I just want to lay them on there and see what I have to start with. Well, it looks pretty decent to start with. But you can see there's still little areas I have to shave away. As accurate as that looks, it's still going to take, see the fit up in the front? It's going to take just a little time to get that in the back. That one needs a little sanding. And this is going to take a lot of time. And rather than run off an hour and a half, 2 hours of tape, Think of that sheetrock fit. I am just going to keep shaving away at these little pieces until that piece basically plugs right on. And once it plugs right on, I know I have, hopefully, because remember, you've got a commitment here of probably 500 or 600 hours, and one mistake here, and it's going to be over. It's definitely over. So I really want to take my time. I really want to have plenty of extra coffee. If Les can make it today, I'm not sure. He's got obligations that he has to take care of. But this part of it, once I start getting it as accurate as I can, I'll get a couple of minutes of the video on there. But it just, the thing that people don't realize is they want to, and I've seen it, people building planes on us, like today they get up and by 10 after 9 they want to have this installed and be moving on to the next step. Well, not with a twin-engine plane. That's not really going to happen. This is going to take time. One other thing that I need to account for is not only the fact that this is tipping down, but it's also going out on an angle. It's like a compound miter. The way I'm going to try to account for that, the easiest way, is to simply do this, to take the inside, try to get this just roughly in where it belongs and get an idea. See, I'm holding the pencil flat, trying to figure out exactly where that line should be. And what's going to happen is I'm going to have to take a little more. In other words, the cutout for the wing in this section is going to have to go forward some. Now you can see it's probably hard to see exactly. 1/16 of an inch, maybe a little more. But one of the things that helps, remember we made patterns for everything. Well, how handy is that? We have the original wing cutout from Dave Downey's plans. We just verified that that's right. We know that this has to come forward maybe a little more than a 1/16 of an inch. And we know this line has to be parallel to our little jig, little spruce part. So we can really just get a little head start on our sheetrock fit here. And I don't mean by much. And in this case, I would rather take a little bit, not enough away. Take a little bit at a time. And we'll start with a 1/16 of an inch. Now, as little as that material is, it's always better to take a little bit less, I think anyway, and then go back and do it over again than to take too much and then, or just have to be adding shims all the time. Now, I want to find a cutter that'll take a nice cut out of that. We have these little carbide cutters that these things really work well. You never have to replace the sandpaper. I just think it's better, and in my case, because we're not getting paid by the hour. Now, after a couple more dry fits, you can see where I have to remove this, and you could also see I'm already hitting the motor mount, which is great because tying the motor mount into the wing with a nice tight fit is going to be one of the things we want to do. So we're going to grind away at the back of that mount a little bit, get a nice tight fit, and get these. This just takes. If you're here in person, you'd be bored to death because this really just takes time. And I know a lot of people are just in a rush to get moving. And don't confuse the fact this line on here is not the center line of the wing. That's the center line of our motor mounts. It's a reflection of the other side, so we can use that as a triple check. We have the top edge and that edge. And this is going to take time. And there's just no way, I know, to make this go faster. If you have a couple of helpers, if Les shows up later, it'll be a big help, but it's not something you can't do yourself. It just takes time. Most important thing is, in our case, is having these CAD/CAM programs and these exact printout sheets that Dave made for the B25. Without these, well, we'd be really taking a lot more time to figure this stuff out. Having these accurate templates, so important. That's why I say when Mike or the next guy goes to build a plane, you've already got the templates done. Boy, that's going to save so much time. Now we have the front of this. This part is absolutely perfect, and it's already got all the angles taken into account. Just like cutting, if you've ever used a compound miter saw, that's just what we're doing. Well, what's going to happen is this one side in the back is going to need about a 32nd of an inch of shim, because what I don't want to do is force it down. I want to have that shim already built in. So I just laminated on a piece of this scrap balsa wood. I'm going to wait till the glue kicks off. In fact, it's kicked off already. Trim this off and sand this little bit of a shim in. And that should basically be one side. Now with that side done, then I basically have to repeat everything over on the other side. Actually, as much of a nuisance as this is, I know that it's like putting money in the bank. I know that if I really am patient today, every time I pull out of the wing over or whatever, I'm getting benefits. I'm getting a return on my money here, on my time. All these little shims and all these little angles, and it's actually, when you think of how many angles are involved, you get the angle of the wing taper, the angle of the dihedral, and this way of doing it with this jig, I guess we'll call it, this really gives us, I think, an advantage over the way we did the B25. And not having those engines canted 5 degrees is going to just make shimming and trimming and getting the engines to run. I think the engines are going to run better in this plane than in the B25. And they ran all right in the B25. I'm just always looking for improvement. So we're just going to keep hammering away here. As we start the second side, just accounting for all these angles and all the little variations that we have to take into account. Well, the first time you do the first side, well, you know, it's really difficult because you've got to figure out where these things are all going. Well, the second side, I've already gotten a couple of cuts off of this, and it's going a lot quicker. But in the case of, you know, doing it the first time, there's no substitute for just taking your time. Now, I wanted to mention something also before I forget. Could we have accounted for this in the time that we, in other words, could I have figured out how much of the wing would have been forward and aft on the doubler? Yeah, you could, but you still have to do this fit. See, that's the problem, is there's no saving. It's like if you're buying sheetrock for a house and the ceiling is 7'8", it doesn't matter if you buy 12-foot sheetrock or 8-foot, except for the fact there's some scrap. We have to make these cuts and angles, and all of these things have to be done on a final fit basis. You really can't do it, and not a way that I know of, like to do it in a jig. Then the other problem, if you do it in a jig, each one would have been different. So this way I know I had to take about that amount out of the first side. I know that's probably what's going to happen to this side. It's probably going to be pretty close by the time I'm done. And I know this way I'm getting right up into the motor now also. As we get closer and closer to the final fit, we're taking smaller and smaller pencil lines or ice shavings off, but we're really closing in on this quicker than I thought we would. But I'm really not going to settle for anything but a fit that's at least the minimum of a thin pen line. I don't want to be out even that amount if I possibly can, because I know all these force arrangements, when they are right on the money, It is just so much easier to fly the plane. It's so much more enjoyable. Forget easier. Just more enjoyable to have a plane that's true and honest and not always fighting you every step of the way like a teenage kid on drugs. Now, after a coffee break and relaxing a little bit, wow, this really does get intense. One of the things I just wanted to mention too is, like, I love to watch these home shows. I love Norm Abrams and some of the Yankee craftsmen and all these people that really are artisans. But one of the things they do, and it kind of galls me, is you watch this show, and all of a sudden the guy says, well, we have to fit a piece of molding to this and he goes to the saw, and the saw's all set up, and how did he get it set up? That's what I want to know. You know, this is the part I wish they would show on home shows when they're making furniture and stuff, is how do they get these fits? Now, we're closing in on it. We're certainly not there yet. We're a couple hours away from it, but this has gone a lot more pleasantly than I thought it would. Maybe it's just the fact that I'm lucky. It's usually, when something goes good, that's usually the case. But we get to this point, and now I'm looking for those little spots that I have to shim with balsa to fill in the gap. Now I can see I have a hard spot right here, so I'm going to mark that. And I have a hard spot right here. So we're right about at this point. Let me see if I can get a pen. Get this right on the money. The hard spot that we're dealing with is right here. And even little amounts like that, when they're shaved off, and it's just back and forth, back and forth, back and forth, until I get this right. The point where we probably have enough material taken off with the Dremel tool. And I want to get the last few spots. I got to get the phone. The last few spots I'm going to take off with by hand, as I don't want to go too far. I don't want to make this too deep. I'm just taking ice shavings off now. Let me get the phone. And each time I do this, I'm making sure I radius this off so I don't get a lot of little hard little cuts in the wood. Now usually the side, I picture what's going to happen, the angle, the side that I need to add a little material to is always going to be the outside. Just this last little bit I'll do with a balsa shim, and that takes into account our dihedral angle. You might be thinking, boy, is this boring? No. This is we're correcting 100 wing over pullouts in one shot here. 100, hopefully thousands. We are getting so close that I'm starting to get excited. We got to take the outer one and just make the chicky off my head. God. And the inner one. We are absolutely within a pencil line. Yes. Wasn't sure at the end of this day if I'd have a helper here at this point in time. Didn't know if Les was going to be able to make it. Because now we're at a point in this where it's a two-man job. So what I did, I had to improvise something. I had to take my block and run a little piece on the bottom that's a support. And you can see this part is going to lay on the table just so I can do my final measuring. So I need to have an extra hand now, and that's not going to happen. Now, I don't know exactly how I'm going to get this on here now. This is pretty interesting. Anyway, I didn't really think this all the way through. Let's see, just going to do it. These were just keeping a wing from sliding back. Okay. Now, even though I have to hold the tension, now I can go around at all the positions and see if my lines are parallel. Actually, what I could do is just put one tack of glue back here One drop of glue would probably do it, and then I could measure. It's under tension because this piece of wood isn't straight. Actually, I could shim the wood. Let's shim the wood. It's easier to shim the wood at this point in time. So to get that angle, I'll just put a little piece of shim down here, and that'll hold this down. Okay, I put a piece of 1/16 shim under there. Again, if I had a helper, obviously, this would be a little bit easier. But there's a point to all this. The point is, you don't always have a helper. In my case, you know, you do sometimes, and sometimes you don't. But anyway, now the next thing is going to be to jig this up in such a way. Let's see if this does it. I'm not sure this is going to do it. No. I need to jig this up in a way that I can, again, can measure from this top of this line down to the table at all four corners, and with all four corners, I'm going to just hold this, I guess. I guess I could glue this to the table. I could glue the shim to the table. That would do it, sure. Yeah, I don't care about the shim. I can just glue it to the table. And if it's wrong, I'm just going to break the shim. Now I'm just making sure I'm not letting this go. I've got this glued down. This is in pretty solid place. Now I can really look around. I can see whether I need to go any other little spots. And boy, this makes looking for the hard spots really easy. With everything in place here, I can set this. Now I know I just need to just tack this down in the back. When that's tacked down, I think that's going to be as accurate as can be. I don't think we're going to get it a lot more accurate than that. I'm going to tack this in place now. Now, I didn't know if I was going to be able to do this with a helper, with two helpers, or of course the usual helper. Hey, helper, what am I paying you for? Anyway, I got this tacked down. Everything is tacked down now. I double checked all of the alignments. And we are just not off anywhere. I mean, these are nice tight fits. And what I'm going to do is just put a temporary glue seam, maybe just on the inside, because then I want to take the jig off and recheck it. Make sure nothing springs or jumps or moves or whatever. But I think right now we have about the best chance I could have ever expected, given the fact that I'm doing this alone. I think we're going to be in real good shape. But again, it's always having a reference datum line. Once you have a datum line and then checking, once I get this jig out of the way, I'll just verify, because I did check the wing several times, verify that my wing hasn't moved and that these 6 points, that they all are equal from the table up. And having that John Pothier tool, that's just as handy as can be. That's just really nice. It really worked well. I know I hopefully have real good alignment here, and I really hope that I've brought some integrity in the building process here. Even though this has taken the better part of a day, it's an investment, just like putting money in the bank. I think the thin CA is the best to get in there first. Again, this is not, I still could break this apart if I had to, if something changes when I take all the jig fixtures off. But this is just one way that, even if you're working Chicky, sorry, I am by myself today. Chicky's not helping me at all, other than just sitting on my head here. Don't you love how whenever you drop something, the caps are right on a spot where you'll definitely see it? Anyway, we're not concerned really with the silver finish right now. That's all we're going to get. More coats. You're getting a nice fillet in there. I also want to make sure no kicker at this point. I just want it to sit, kick normally, and then any gaps I have I'll fill with the gap fill and Brodak. Slow drying. We have plenty of time now. Now the hard part is over. Now we're on the downhill side of this. Once we take the jig off and recheck it, it's going to be time for a giant cup of coffee. Now we have the permanent glue joints. We've checked all the alignment. And the only thing left to do is to take the jig, I guess, off and recheck our 6 points. And once that's done, I'm excited. I think this is going to be one of the better alignments that I've done. And if there ever was one part of a plane that I would love to have right, I mean, if the finish is a little ratty and you cheat the time you spend finishing it, well, that's one thing. If the plane's a little heavy, you can trim it a little differently. If it's underpowered, if it's this, if it's that. But if it's crooked, and I've spent some time on the last tape and this tape trying to put forward all of the little things that I've found really have helped me. There isn't a single reason anybody can't do any of this. It just isn't any trick. It's one of the things that, and once you learn how to do it, from that point on, every plane you build will be perfect. Should be, or if not perfect, it'll be a lot better than if it's crooked. Safe to say that our fixture has done what we paid it to do. Good boy. Now with the jig off, I was hoping everything would stay stable. It did. I think this was just a good way to do it. We could break these off. I'll cut them with a brand new blade. I don't want to take a chance in breaking this. Dress off that edge. And I think it's safe to say that, well, I don't know if it's ever safe to say it, but we certainly have got this started on the right foot, and I think we got it going in the right direction. Well, one thing convenient I didn't even realize, this makes it very convenient to work on the wing here when it's in this mode. The next thing I'm going to do is just fill in this little gap between the motor mounts and the wing. Shove a little piece of shim down there. I want to fill that in. That's the joint that I want to make nice and secure. Just fill those two little pieces in. Some thin CA. I'm not sure what else we're going to do today, but I'm just thrilled to death that we got this much done. This was a major thing. I'll really sleep like a baby tonight. I got the little filler blocks in what will be the back of the tank floor. And of course what I need to do now, I need to make the back bulkhead. I got some sea grain wood scrap at just exactly the right size even. I need to make what's going to be the back piece and make sure that my 5-ounce carbon fiber tank somehow fits in here without being too cute. And that looks like that's going to be just about the right size, because I really want to wind up with about 4.5-ounce tanks ultimately, and I hopefully will not need 5-ounce, but I want to have them just in case, be able to get 5-ounce tanks in here just in case. Now by taking these out, and again what I'll do is with a triangle, make sure I don't have this crooked, and make sure I don't have it crooked in this dimension before I glue it. Now with that bulkhead tacked in, I probably have enough material here to make the other side of the tank. Now, of course, just get the other side done. Now with the two backs done, now the next thing is going to be to get some See if we have some C-grain balsa that we can make the tank floor. What's going to ultimately be the tank floor here. I hope we can find a piece of nice C-grain, because I want to get a nice tight fit on the inside. All right.
Elmer's.
This was thinned Elmer's glue, 2 pieces of 32nd, if I remember right.
And lightweight carbon fiber mat.
Okay, and a piece of mat in between, if I remember when you laid this up. In fact, I got to get the twin off the table. The twin's sitting over there on his comfortable pad. Yeah, this I think should have, let me clean the table off so you got a place to work. As Les is unwrapping a mummy, we're going to look at his retracts, which he bought. Where'd you buy these from, Hobbyco?
From Tower.
These are from Tower.
Now, do they make Hobbyco? Or is that a separate?
I think they were in the Mafia. I'm not sure how it works. Anyway, what Les did, we looked at these while we were having lunch. These are rotational. They rotate.
As they come back, like Corsair and P-40 Warhawk.
Yeah, Warhawk, Corsair, and a Skyraider will rotate. The only problem is, number one, the most obvious problem, these are what, 7 ounces?
The pair, without the axles, is 7 ounces.
These were way too heavy for Les's project. And to me, when I look at how they're engineered, they're not really brilliant either, the way they've made them. I think Zambelli could make something better than this set. I think you and I could make something better than this set. But anyway, a lot of times you have to find out that something's not appropriate by, well, in this case, by buying it. Also, show the motion on this, how hard that is to move. There's like a tremendous, that's the good one.
Yeah.
Well, actually, and one of them was broken when he took it out of the pack.
Right. Well, the problem stems from the fact that you're moving this arm here. It slides back and forth. All right? And the geometry is such that your pivot here is far too close. You have no mechanical advantage. So with a great deal of easily you come out of the lock mode, but when you start to move it, and then when you approach the lock on the other side.
Imagine trying to do that with 2 of them.
Yeah.
I mean, you're only doing 1.
Right. There's a lot of force.
Yeah, so I'd say that's one of the little disappointments of the Skyraider program here.
Well, it's one of the disappointments of retracts thus far. But, it doesn't turn me off.
Before you go spending a bunch of money, think about it or look at them in a hobby shop. These are really, I don't see any way you could adapt those to use for our purposes.
Sure. I mean, you could if you wanted to build an airplane with a 22-ounce.
Yeah, these belong in a 10-pound airplane. That's it. But what's wrong too is the way they mount this way. I mean, the side load on this would be, there's no way you wouldn't rip that out eventually or rip the plane apart. This should be on a bigger footprint, probably 3 or 4 times as big, so it wouldn't be so prone to side loading.
That's why I like the idea about making these vertical plates the ribs,
right,
and then running a pivot tube between the ribs and even into the next bay if it's carbon fiber. It doesn't weigh that much, and you have a perfect axle.
Right, so we learned something from this, but I'm not sure these would be usable for anything that we're going to be building in this shop in the near future.
That feels.
This is the double A? Oh my God, it's 5 times as stiff.
As regular ones.
Incredible, yeah. Well, the way when a guy's launching a plane like this, you do need some strength there. So what I do, I always seal it with CA inside.
Yeah.
But you don't have to seal that. Boy, that's a keep. That's a keeper as far as I can tell.
All right, so we got something that's usable.
Every September, the scenic and
So the leading edge looks like it's a go. And what about this? This is the little part that's been sitting there since I went for surgery.
This is what we put together.
Okay, I don't even remember. Oh, with the mat in between. Okay.
It's 2 pieces of 1/32 with the mat in between and with white glue. Feel that.
Okay, it's cross grain. Ooh,
yeah,
that's
but
nice.
So my point is, even with white glue, you don't have to use epoxy for that stuff.
That's definitely nice. All right, save your weights. Don't throw out. Look at the note he puts on it. Save, do not throw me out. Don't throw the baby out with the bath water.
Now this was stuff we put together with
2 layers in mat.
But it wasn't with white glue. It was with CA, thick CA.
I think the white glue is better. It penetrates better. Boy, that's solid as a rock.
Well, see,
That's
the
nice.
one thing that I was worried about was generally when you lay this up with white glue, it
Yeah,
works in flex.
well, if you keep it under pressure.
Keep it under pressure, let it cure out.
Yeah,
What you got?
and make some kind of clamping thing with 2 pieces of glass and 100 gallons of Brodak dope.
Yeah.
Yeah, something like that would be fine.
Whatever.
All right, so that's 2 things you got in the bank, so to speak. Hey, we're watching this. I got to get this sooner or later on the video, too, this tiger cat that's on it. There's not much footage of it, but they're flying a tiger cat at the 2002 Reno Air Races. I know Les doesn't like tiger cats, though.
Oh, tiger cats are cool.
No, a tiger cat is cool. All these videos, we got 4 or 5 of them now from Warren Walker. Actually, there's a news report on this where the newscaster comes in and he's one of the people they interview. Very, very cool.
They interviewed Warren?
Yeah, they interviewed him twice. Well, he's a, you know, he goes every year. He lives only a couple hours away.
He's knowledgeable.
All right, now this is the wing that Les made up. When did you make this up? I don't even know. We're lost in a time warp
What year
here.
is it?
Yeah. Okay, what we're trying to do, we're trying to take a piece of paper and make a schedule up because what we want to go into full production on working on getting his plane. We have, 89 days before we leave for Texas. This plane's got to be in the air in 89 days.
Plane's got to be in the air before that.
But anyway, this is the wing he made. I think this is the one with the gear blocks in it.
Yep.
And we want to set up the push rod. Now, he wants to have one of those Noel Drindak push rods, so this will be our first chance to get one of those on video. You got the patterns for the wingtips back at your house.
Yeah, right. Those I'll bring with me tomorrow.
Okay.
We'll sort those out.
You're gonna leave a set of plans here and home, so you can, bounce back and forth.
Yeah. You know what? What do we got for wingtip wood?
We got plenty of wingtip wood, right? Especially outer tip. We're covered on outer tip for the rest.
All right.
Tricky's got the inner wood inside. No, we got wood. You just need the pattern. And then we got to make
them. Cut them out on the bandsaw tonight at home.
Okay. Well, let's go through it. Make extra ones. Make my set while you're making them.
Okay. Yeah.
Because I want to make one of these planes too, of course. But our primary thing here, that's what we're trying to decide to do today, is make up a little production schedule. We have 89 days before we're going to be leaving for Houston, Texas, and
okay. So tomorrow when I
less promises by this. Well, I've heard this before. Boy, promises, it's a lot easier to talk about it than do it, huh?
No, it's not so. Well, the biggest grief that I have right now is working around Mom's situation.
Well,
but I mean, that's.
And you're going to take that stuff. Well, Walt Brownell just sent us some stuff regarding electrics that we need to make copies of and read in detail. No, don't worry, we're not going to forget it. But absolutely fabulous. Walt Brownell is now in second place, right? Maybe he's in first place. I don't know. But I know we're not. But again, because we have all these wings, the objective here is some of these wings are going to wind up in the electric plane. Some of these wings are going to wind up, the nicer of all of them is going to wind up in Les's plane. And then some of these wings, I hope, eventually are going to wind up in my Testarossa. Just finalizing that, what I'm going to try to do is get the wing prepped for the bell crank. Now, because this wing has a spar and gear blocks, we're going to have to put the bell crank bolt just behind the spar, which is not a big deal, but we still have to remove the material where the spar is so that the bell crank can pivot without hitting anything. What we did ahead of time, trying to prepare for tomorrow, where we're going to try to join a wing, we made up a little the line adjuster from some laminated spruce that Les had. And Les has the wing gutted out for the bell crank. We got a little more to take out. He doesn't have the part for the bell crank. What we're trying to do though is stage everything, get it ready for tomorrow. You have the wood for the wingtips?
Yeah.
Okay, wood for the wingtips.
Ready to go.
And he's got his little list. So the plan is tomorrow to be in full production mode and get this puppy together.
It's one of the push rod sets.
Oh, does it have the parts that you need to hook up this end?
We can put one end of it together, yeah.
Okay, let's see.
Then tomorrow when I
Let's
show
see how
up with
this
the
goes
horn.
together, yeah. So what are these, the thin arrow shafts?
Yeah. They're 3/16 OD, 1/8 inch ID.
not as strong as a regular arrow shaft.
They don't have to be.
And it only took us 2 hours to find.
Yeah, right. To find the shit.
Oh, all right. So he's got all these rinky-dink control horn things here. Let's get some. Now let's see. What is that one?
This is the flap horn.
It's two flap horns. Now what goes on there? The ball links go on that, or?
The ball goes between. The 440 goes through this, through the ball, and
out
thread it in here. And you put some nut on there and some Loctite, and you're home free. This one is from the bell crank to here, and this goes back to the flap horn, to the elevator horn, which is fully adjustable. Vis-a-vis these little sliders that I just had in my hand. Oh good, we lost them already. No, they're in there.
Oh, we're having a real inventory problem here.
See, this button head.
God, there's so many parts to this. Like putting that helicopter together.
But the nice part about it is, if you find the airplane responds better, Wendy, to let's say 35 degrees of flap movement to 45 degrees of elevator movement, guess what happens? You can dial it right in.
Yeah, but you know what happens when you put an adjustable horn like this in the back of a plane? I guarantee you one thing.
What?
Wherever you set it when you build a plane, that's where it'll be the best.
Well, you set it at
If you put one in that you can't adjust or it has no extra bushings,
you set it. You set it.
I'd start. I assume that's what this is here. This thing is big enough. Holy mackerel! Wow, some heavy-duty stuff here, baby.
But see, the nice thing is you got the ball link and double shear. If you're using, this is overkill. If you're using,
you could use this in a 60 ship. Sure.
Yeah.
Sure.
Well, it's 1/8 wire.
No, there's two of them instead of one.
Yeah, right.
It's like having,
Well, that's what they're made for.
Two of watermelons weigh more than one watermelon.
60.
The whole plan here is that tomorrow Les is going to get here real early with bagels. We're going to fire up the furnace here, and tomorrow we're going to work on this wing. Try to get it joined. He went home with the tip blocks ready to rough out. We made up parts of the control and tip weight, the adjustable lead-out system. So tomorrow I hope is going to be a good production day. And I hope it doesn't snow so much that he can't get here. Tonight after supper I decided to come down and get a little work done on this. I was so excited about getting these Nacels, the pods on. But what I thought the next step I want to do is I want to get a piece of cross grain, probably 3/32 would be the best. Get a piece right in here with the grain going side to side to complete what's going to be ultimately be the tank boxes for this plane. And of course once I make a pattern, making a second one, even if I get one little step like this done before tomorrow, I'm really psyched up because this part of it, all through the time I was recovering from surgery, I was thinking about it, and when you think about it too much, you start thinking, well, maybe it's going to be harder to do, or it's not going to work out as I really planned. What actually happened was it worked out better than I ever could have planned. And while Les is home making up some parts for tomorrow and bringing all this stuff for tomorrow, we're kind of psyched up about having a production day tomorrow. What I call a production day, where we don't fool around and we don't watch windy videos or anything. We strictly try to get something done. Not sure that always not sure it ever happens, in fact. And that kind of just frames out what will be the tank floors. A little bit of time I had left. I thought I'd make up a pattern, because this is what we're going to have to superimpose onto those bulkheads that we made up previously. So I wanted to get just a rough idea of it, if this was going to be the way I wanted to do it. What I want to do is I want to have this bulkhead contact as much of the mounts as possible. Of course, we got to allow for the tank box. Yeah, that's going to be a reasonable enough fit. And then what I'll have to do when I cut them, and I'm not going to do them tonight, to figure out the exact center of these bulkheads, and in which case I can put a compass dot and then transpose this right on. I think that's going to be, well, anytime I could do a little detail, see? Even one little detail like this, before I go to bed at night, I'm one step ahead of the game. And the truth is, since I've been feeling a little friskier and better, I can live with a little less sleep. Time I need to know whether these late nights and early mornings and all of these times we put into the models are worth it. I just look over at the B-25 and I wonder how much different my life would be if I never put the effort into this, or into the train layout, or into the Typhoon, into anything. There's almost a direct relationship, I think there is anyway, into what you get out of modeling and what you put into it. And if you make the commitment and put the time in and the energy, it almost guarantees you're gonna get something special out in return. I'm going to bed. Now, I got up real early this morning because I wanted to get a couple little things done before Les got here, but they're predicting a giant snowstorm, so I don't know what's going to happen. Anyway, what I did, I laid out what the cut for some of our formers, and I thought this is really getting to be very time-consuming stuff. What I wanted to do is take all the patterns, make me patterns, full-size patterns for what will be all the formers. There'll be the forward two. There'll be one that rests there and one that rests on here. And I need to get it real accurate lines for the cuts, because I want these to be a nice snug fit as I push them up into place. I don't want to have a sloppy fit there. So again, what's a good idea whenever you have a little job like this? And of course we're saving every pattern, so hopefully Elliot or somebody can draw plans for this plane somewhere down the road, and then it'll help Mike build it. But a job like this, I don't know that you even can put step by step here, because I'm trying to estimate that same thing, that sheetrock technology. In other words, every time I go to shave this or make another copy, I make sure it fits right in place, and this would be the former that fits on here, while the next one is going to be the one that goes all the way in the back. So it has this hole on it, and it has to account for the bottom of the tank box back there. So it just turns out, on a project like this, it just turns out to be a lot of little detail things that one by one all add up into being very time consuming. But when we're done, the objective is, of course, to have a real nice set of plans for what we're doing. And if I didn't take the time to make all these copies, well, I'd have the plane done in the case of like the B-25, and then I couldn't use all of those patterns to go on to make another plane. So even if you're building a simplified plane, it's always nice. And these are the ends of notebooks. This is about the right kind of cardstock, or the worst that can happen is you just go to Staples and buy some cardstock. This is probably a nickel a sheet or something. But having these plans is going to be a big step forward in the overall, I guess, when we go to do the second one for Mike Costello, or anytime Mike does it on his own, he's not even going to need me, hopefully. In the way this winter has evolved, and with my operation, and with Les his mom is actually in pretty poor health, needs a lot of attention from him, so we don't plan anything until we find out how she's doing for the day. But having these little templates, now of course if somebody drew all these templates for you building a plane, it'd be a whole lot easier, but this is part of the challenge, is getting nice tight fits and getting these to be made. We're going to make these out of the laminated balsa that we already made the formers, the rough size formers. So again, this is what makes it challenging, what makes it interesting, what makes it just a little bit different. And this one, of course, is going to have to go behind there, laying this all out. I guess it's one of the things I enjoy the most, is this design phase of the model. Now, one thing I've learned about making these kind of templates and patterns and whatnot is you're always better off making everything a little bit tight to begin with. In this case, maybe the thickness of a pen line tighter than it has to be, and then dry fitting it, just like those sheetrock fits, just little by little by little, try to get the fit. What happens when you try to get it real tight on the first shot, in which case I'm always trying to do that, but I always wind up making it 3 or 4 times. But the end result is I really would like to have these to be a nice tight fit for a lot of reasons, not only for structural integrity, but the front part of this is going to be where you're actually going to be inside the cowling. You're going to actually see it when you look inside the cowling to see the motor. So now it looks like that's pretty much going to be the shape that we want to have. We're going to have to remove this piece in here for that first pattern. That's the one that's going to slide up close to the wing. But the lousy thing that's going to happen if we get another big snowstorm, it's going to really throw us another curveball. And because Les has kind of made this timetable that he wants to work from, well, you know, we all start off thinking we're going to have this timetable of unlimited time, but in Les's case, it's his mom. In my case, it's just a lot of other things that I have to work around. And as if that wasn't enough, we're just adding around it. This is probably the lousiest winter of all times around here anyway. We have really had some terrible weather. Well, I scored this, but I tried not to cut all the way through because I didn't want to. There we go. I want to get nice tight cuts on this. I wanted to save this piece for whatever reason, just because it's one extra thing I won't have to figure out later if I need to do this for some other part. So you can see one of the things now we have to take when we actually make the part. I want to move these lines over a little bit. What I do is I do that usually with a little piece of tape, or I just memorize where they have to be tighter. This side here has to be a little tighter. But other than that, that pattern's almost ready to make parts. But again, I'm only just trying to fill in time here, working around all the things that I normally have to work around in the shop, and plus the weather and, well, other little obligations. But still, to get up early in the morning before the action in the day starts and get a couple little parts made, this is just going to allow me to get a little bit further ahead than I normally would be. I established the center lines on everything. What I need to do here is I made little notations. I need to add an incline of material here and an incline here. So when I trace that out, I'll just make that a little tighter. But I can actually make that now on some of those cross-laminated former blanks that we made. Just getting a couple little things like these formers, and every time I can get one little piece of this puzzle made, whether I do it early in the morning or late at night, I just feel like I'm moving the football forward, moving it down the field a little bit, or whatever. And what's happening to me now, and I'm aware of it because I know this has happened the same way with the B-25, is you get to a point with this, and it really starts to look like the airplane you envision in your mind, and then it's all you can think about day and night until you get all the framing done. And the framing on this is going to take quite a bit more time, but anytime I can get even one little piece like this morning made, as has happened constantly in the course of this winter. We've just had some plans that have had to change. Les is not going to be in the shop for a couple of days, maybe a little longer. He's got some things he has to do caring for his mom. So what I decided to do here is basically as fill-in time. I wasn't going to do this. We were going to try to work on Les's plane. But I do have some of the templates made up, and I thought, well, I've got a snowy afternoon here, and I'm not well enough now to shovel, so it's real neat. I get to watch my own kids shovel. But what's nice is, this is kind of nice little relaxing work, so I'm going to spend a couple hours making up some more formers, maybe getting a few of them glued in position. But again, this is just fill-in work, because we really were hoping we were hoping for better weather, number one. We were hoping we could get going on that wing. What I need to do is join that wing, and then Les can actually take it back home and do some of the things like the wingtips. But anyway, as always, we're working around things we can't control. But anyway, having a template, now what I wanted to mention is now that we have a template for that first part, well, you would think anyway, you know, that we'd have a head start on some of these are going to go very quickly. Well, I don't know. They should, but all I can say is it's, in my case, it's just real important for me to have a pattern for these things, because boy do I hate having to make these parts over and over again, when in essence I can make one and then make the second or third one relatively quickly. So what happens at the end of this project, I'm going to wind up with a whole envelope full of these patterns. But should Mike be able to use them, or if I can use them on some projects, these are going to pay for themselves somewhere down the road. And what I'm really looking for is some nice tight fits and some good integrity. I don't want to have to fill in around all these joints. I'd like them to be as tight as possible, of course. But I can always add to the pattern. Of course, I did this the other day, where I needed to add the pattern's a little oversized, add a little bit here. And if one side's a little bit more than the other, I just put a plus mark there. And that's how I know when I make the next one up from this pattern, I'll know I've already taken into account, I don't have to do it 2 or 3 times, I've already taken into account that little material about the thickness of a pen line that I have to add. Also, I found a couple other little tips. I see the battery light coming on. I don't want to lose the battery here, but a couple other little tips that'll be helpful in cutting out patterns here on this part of the project. Okay, sorry for that bad cut. We had a battery go dead, but what I wanted to make sure I include on the tape is that I'm constantly maneuvering and adjusting these to make the complementary part. But when I do that, always making a notation, otherwise I'd have to make a new pattern, and it wouldn't be cost effective to do that. So by having these patterns, now the second one will go in about 1/10 the time the first one goes. The first one has to be dry fit and have all the edges and angles and everything cut. And what's important is on this center line, that when I line up that center line, it lines up with the top of the motor mount pad. Otherwise, what's going to happen is when I put the cowl on, the crankshaft of the motor is not going to be in the middle of the cowl. And then I'm going to have to make shims and everything. I'd like this all to be real nice and straight right in the beginning. Hopefully that will happen. But making these parts up, again, I found the easiest way of all on a cutting pad. It's a Brodak XL cutting pad. Using a brand new blade, make them leave the little amount that the pen line affords, makes it a little bit of a tight fit. And then what I usually use, and Bernie Trent sent these little sanding, he calls them sanding twigs or something. Well, I don't have the label here anymore. But anyway, these work nice to get in all the little angles and get in all the corners and get nice 90-degree corners. These are a nice find, and these are from Bernie Trent. Let me start cutting up some parts here while we have some time. Now I wanted to mention something. Part of what I do on a regular basis, and I always try to include little quips of it on the video, is I try to use time management to my advantage. I don't really have as much time as people think I do, but I don't waste a lot of it. Now a day like today, it's snowing outside, I can't even shovel my own driveway. But I've made up a little hit list of about 8 or 10 little projects I can do that'll get me ahead, that when we actually do get some nice weather, or we do get some nice time, I'm not going to be doing projects that I could be doing right now. Using the time effectively, and in this case, because Les is on a little bit of a sabbatical, we were going to work on his plane. We've had to change the plan almost overnight. But we're not going to waste the time sitting around. We're going to try to make up some little component parts. And that's what's allowed me to build planes like the B-25, where there's 500-600 hours, man-hours of work. And a lot of people say, oh, well, he just has nothing to do all day. Yeah, well, I wish they'd come hang out at the shop for a while. The people that say that usually are the ones that do have the time, too. But anyway, it isn't a question of having a lot of time. It's a question of using the time effectively. Example is while we had the time and before we had the other complications show up, is to get all these parts made up, because now a day comes And I can't work on a project like this, you know, and feeling the way I do. I'm still kind of in this semi-recovery thing. But I certainly can work on making little bulkheads. Well, I wouldn't want to just lose this day and then, you know, be 2 days behind. Because we really do like to see progress, even though we're not having a race. I like to see progress on the parts. And it just allows me to plan out things that when I'm able to work on what I call two-man jobs, that I have less around or I have somebody around to give me a hand. When I have jobs that I can do on my own or I can get a little bit ahead on, make some extra molded parts while I have time. Those are the kind of things that when you schedule things correctly, you find out you can get a lot more done than when you just randomly pick projects to work on, or you just pick something that there's a saying, I think it's from the Navy, that you never stand up when you can sit down, never sit down when you can lay down, never stay awake when you can sleep. I'm not sure if that's a correct quote, but I do know in my case, planning these things out and trying to make them efficient allows me to get a lot done in not a whole lot of time, and that's what I try to pass on through the tapes. Make a case up here because I've been so bored. I've been watching my railroad video over and over again. But when Roger Carp was here, one of the things he went on and on about, he says, most guys that build a railroad, geez, it takes them a minimum of a year and sometimes 10 years. And I said, it took me, I don't know, a few months, 3 or 4 months maybe. Well, the reason was I didn't waste a lot of the time. And all of the things I had to do, I kind of scheduled them, worked late at night, got up early in the morning. I really did get a lot done relative to, I guess, some people that they kind of fiddle around and don't get a lot done. Anyway, just something to think about while we go making up some formers. And thanks to Bernie Trent for turning us on to those little sanding twigs. Those guys really work great. I remember as a kid having bought kits and none of the parts fit really tight or fit well at all. This is where having these parts made, we have an exact center. That's important that we know where that exact center is. Now I can estimate, and I can do it relatively accurately, just by working around the perimeter, where that is. Make sure I have it as accurate as I can get it. Actually, when you're making a round fuselage, it's a little different than making a traditional type fuselage. Now, what I need to do is, after I have that in place, I know where the center of this is going to be. Well, the first thing is to get a center line on each former, because we're going to work off center lines. One of the things a lot of people they're new to building don't really realize how important it is to have everything on center. That's my center right there. Now, to get a 90-degree center on this, you can use a triangle or any of several other ways, but getting a vertical and a horizontal center line that I can transpose all my cuts on. This, by the way, is another great place to get a brand new blade, so you don't tend to split the wood. Now, from that, I have this part, and I have the center lines already on here. So you can see what I need to do basically is line up these I call them adjusted center lines. And now what I do is, to hold this in position, put a couple of these John Pothier pins in. Now I know, for instance, this line is relatively easy. That one didn't need to be trimmed much. These two, the bottom was fine, but I needed to move in just a little bit, a 64th of an inch maybe. So it's always better to cut and leave a little more material and then sand it out than to have to cut too big and then make a filler piece. I'm kind of trying to minimize making filler pieces here. So this will be on the underside. And in the course of doing this airplane, there's going to be a lot of formers. This I know is an accurate line. This didn't need to be trimmed. This didn't need it. These were fine. But this one here had to be adjusted. We had to adjust that in, and I'll make that adjustment right here. Now this would be really nice if we had all these patterns drawn and we had somebody that could just laser cut everything. Well, yeah, that'd be nice, but you still don't need it. It's still overkill. You can still, especially on a day like today when we're filling in. Now see, what we've done is we've made the adjustments to the part. See the little adjustments we've made? And I made this adjustment. So once I cut this out, and I'll use a ruler on all the edges, once I cut this out, I hope I'm going to start by not being way out in left field and having to throw 6 of these away. But it all starts with having patterns for everything, and in the case when we're done with this, hopefully having a real accurate set of plans. This is where these little sanding twigs get right in the corner. Again, anytime we can get ahead, even on 1 or 2 formers, couple of formers, hey, just puts us a little bit, hopefully a little bit ahead. And what we always try to do is just do a little bit of a dry fit. See where the hard spot is. Where we're picking up a hard spot here is we need to have this edge right here is now the hard edge, so I can take off maybe 1 pen line off each side here. Picking up the hard spot, as long as you can find the hard spot. Now to cut a small amount like that is very difficult, but relatively easy. You can see what I've done to this, so I can get in there. And usually you wind up doing this 8, 10, 15 times on a complex former like this. If you go too far, you have to shove a little piece of balsa in between, or whoops, upside down. Well, let's see where the hard spot is now. Where are we? That's about right. That's about right. We need to take about 1/64 on the bottom off. Constantly putting the piece back, picking up the hard spot. Now, the reason I want to have this edge really solid is because this is going to be when the tank goes in, where we pick up the support for the tank. So I don't want to have that to be a relatively weak area. Let's see what I do. I try to work up to that line. Once I see I've gone through the line, then I'm done. And then I'll pick up another pen line. Do it 1 pen line at a time is usually close enough. Now let's just see where the hard spot is now. We're getting closer and closer. Okay, now you can see right here is the only hard spot left. Famous last words. Actually, we're picking up a hard spot right here in this corner too. But I think once you see how I do this once, you can use my technique, and if you have some way even better, hey, we're looking forward real soon to working with Ed Cotton. He's going to be showing us some real tricks for doing the things he does to make a living making architectural models, and I'm sure a lot of it is applicable right to what we do. I guarantee it. When one artisan can show you his tricks and you can show him your tricks, now see that? There you have it. And you've got a real nice tight fit on the whole thing. Now that's how I fit each one of the formers that's going to go on this plane. I also want to verify that I'm on center, and it looks like I'm right on the money if you can see. This would be the center of the motor. In fact, we could lay this would be our crankshaft center line. Whoops, we were right on the money there. But anyway, hope that's information you can use. That's how I'm going to spend the rest of the day, just cutting out some of these formers. I don't need to show every one on video, but that's one, and that's especially on a round fuselage, that's the best way I know of to get nice accurate former fits. Hope that helps. The point is that I want to get anyway, is all these angles for the formers at 90 degrees. Now see, this one is not 90. Sorry, Charlie. We got to get it 90 in two different dimensions here. It's going to come out just a little bit. And once I get these in place, then I'm just going to tack them in place. And any little accuracy we can pick up here will just make, when we do the sheeting, we haven't really made a final decision on that yet. Okay, we've got that 90, that 90, that 90, that 90. Now we can just tack these in place, just to keep them from moving. Once we know they're in a good position, then we'll run a bead of thick CA, slow drying CA around the whole part. So I just want to tack it in place first, wait, double check it, I'll flip it over and do the other side. The other thing that's a pain is when the formers are like this, and they're sticking up, they really are vulnerable. You really are prone to, well, every time you move the wing, knocking one loose or breaking them. I remember on a B-25 breaking the formers every time I worked on a plane. Now once all these tacks dry, and I know I've checked all my fits, the next thing is I take the thick CA, the Brodak CA, with the point, very, very small hole, so I can kind of inject the glue into that seam, and any gap there is in there, it'll fill in the gap at the same time. And of course, if possible, try not to use any kicker at all. Once that glue is down there, then one side of a fresh Q-tip makes a nice radius fillet. Once one side dries, I'll do the other side, flip it over. But I've pressed that thick CA down into the joint, so any gaps, it's called gap filling CA. Well, guess we'll find out. Anyway, and that's one, and I just can go over from back and forth, get those two formers in, and I'm ready to start working on the front formers then. Okay, the next step, and I don't know if I'm going to get this done today or not, is I have the next form is made up. I use the cowls themselves to spot where I want the blind nuts. Now what I'm going to have to do is make up a little piece of plywood. In fact, I can use light ply here. These cowls are so light. Some 440 blind nuts and little pieces of light ply that'll go on the back, and I'll put the cowl mounts in position before I actually put this on. So this will be hopefully a pretty good fit. And I mark the cowls. Where is this one? It says which one is outer and which one is up, just to make it easier when we're going to be working, taking the cowls on and off, on and off. Always good if you can use the cowl itself to get the alignment. And what I did, I sharpened up a piece of wire so I could reach down in there and poke the hole, get it started. And then I verified it against our cowl mount to make sure we're not making something crazy here. But of course the cowls won't be interchangeable because the exhaust will be on the wrong side of the cowl. So I want to make sure I know which is which, and every time I put them on and take them off, I don't have a problem. So the next thing is going to be to, and I'll do it off camera, make up some little pieces of scrap plywood or light ply. In fact, I think light ply will be fine. With some blind nuts in. Put some bolts in here temporarily just to bolt it together, and now I want to install this whole thing as a unit. I laid out the 6 hard points that we're going to need. Put a little bit of chain lube in the threaded parts. I'll cut this out with the jigsaw, and then what I'll do is attach each one before I glue it, get the bolts holding it in place. Then once the bolt is holding it in place, the bolt will be a self-aligning part, and then I can grind off whatever hangs out the edge. I think that'll be a pretty accurate way of getting these cowls in place. Now with that bolt holding it in place, the best thing here is, and I could think of doing it, is just get some thin CA on here. And we'll build this up with a little thick CA once this dries. I don't want to overdo it because if some of this CA drops down into the cowl, we'll glue the cowl to this part, and that can definitely happen. So hold it in this position while it dries, and then we'll just go do the other bolts. The reason we know these locations, and this is going to be the top, looking at the model when it's sitting on its landing gear, we know that the cylinder of the engine sits down here, and we can get a wrench in here, and of course the top one is easy to get the bolts out, and that's worked out very, very well. One of the really nice parts of the B-25 was having figured that out, not knowing how it was going to work. Certainly 3 bolts is safer than 2 in case one even does vibrate out. 2 should hold it in place. But the blind nuts are on. Now what I can do is thoroughly go by and soak them. Now if I were to do this while the cowl was in place, every once in a while you'd be gluing the cowl. And I guess we've all done that, glued tip weight boxes and things. This is why I put the lubrication inside the bolt hole in case a little bit of this drips down in there. I'm going around the area where this is going in the wood just to harden up the wood, harden up the edge. Of course this will get trimmed down. The thin CA will soak this up, and since it's really balsa plywood, it should be relatively strong, and we should be able to actually catch this on what will be the skin. Now, about an hour ago I spoke to Les, and he wants me to put his push rod together because he thinks maybe he can break away from his routine tomorrow, come over for half a day. But even if he can't, I'd like to have that push rod on video. Les is wanting to try this ball link adjustable kind of a Noel Drindak push rod, and I haven't actually used one as such yet, so it'll be a good chance for us to experiment with it and do it on his plane, not mine, which is even better. Poor Les. Just do a final trimming here. This will give us a real good 90-degree edge to where that's going to join. We want to catch the skin there, of course. Before we glue this in place permanently, You want to make sure everything is 90. We'll do the same trick, just tack it in place first. Then check it before we put a permanent glue seam on it. With some good luck, these bolts are just going to be in a very convenient spot here. Once this is tacked and all these 90s are checked, and tomorrow I'll just get to make the other side up, but in the meantime I want to get Les's push rod made up. Alright, now I'm just trying to get this information up on a video. Awesome push rod, I can't read what's under Essential Hobbies. Here's the order hotline, 800-723-5937, Billings, Montana. Anyway, congratulations, you've bought a push rod, da-da-da-da-da-da-da. Now, there's only a couple of things that I don't like about this. And of course, I'm an old school kind of guy. I'm kind of a wire guy, in fact. But I'm not opposed to, if Les wants to try this on his plane, why not? So the first thing is we weighed the push rod itself up. You can't even get this thing out of the package. We weighed the push rod itself up, and the push rod was lighter than a typical arrow shaft. But the only problem is it's half the strength, too. So on a 40 ship, again, I don't think that's a big deal. And Noel has told me many times he doesn't even think it's a problem with a 60 ship. But maybe what I'm doing is just way overbuilding things anyway. But then again, my stuff's around for 20 years, so I don't know. It's kind of a personal decision. Now, what they tell you to do, JB Weld is preferred. Slow epoxy, I can tell you right now, slow epoxy is not a good choice. Gap filling CA, not instant, is definitely not a good choice. But JB Weld is a structural epoxy. An even better choice would be, and we just happen to have some in the shop, but Les wanted to go with JB Weld, is we have secondary bonding resin that's made to attach to this type of material. The metal ends, and in this case they're titanium, the exact diameter for proper space adhesive. Do not attempt to thread a fitting such as a piece of threaded rod or bolt with a head cut off. These are carbon fiber running, unlike a carbon tube, these rods have all their fibers running parallel down a length, which makes them rigid. Screwing something in the end, you will either separate the fibers, cut them, or both, so this is something you need to be aware of. Use the fittings that are designed for the application. A pipe cleaner dipped in alcohol is an easy way to clean a hole. Well, what you need to do with any secondary bonding resin, and I'm not sure what these things are made out of, whether they are, until I cut one up I won't really know. I'm not sure if they, well, there's one way we can find out. Yeah, it looks like there's some kind of concoction of carbon fiber. But anyway, what's supposed to happen here, and this is significant, is this is supposed to be not a press fit. There's supposed to be room for the JB Weld in there. Also, they want you to confine this end so there's no way it can split. So the first thing I have to do is get in there and sand this rough, and get this roughened up too. Even though this has these little teeth, you know what? The problem with all this stuff is your whole model is hanging on this. It's like if you're a mountain climber. The rope that's holding you, this is in the rope. Now, one problem here, and it's